All right, today we will be covering topic 2.1, points, lines, and planes. We're just now getting into geometry with this. At first part of this unit, we will be doing a lot of definitions. We will be defining what a point is, what a line is, and what are some other lines that you might see in geometry. And also, we're going to define some planes in this lesson. All right, so let's look at your notes. And let me pull out what I've got written up for our notes. We're going to talk about terms. We're going to talk about their description or their definition. We're going to show a sketch of the term, and then we're going to talk about how we name the term. So on our first page, this is what we're looking at. And we're going to start with a point. A point is an exact location, in space with indefinite shape and size. Shape and size. Now in geometry, you've got to imagine a lot of this stuff you're going to have to see in your head, especially when we get into nets and other figures. You're going to have to be able to see it in your mind. And a point, a lot of people and a lot of us, we define a point as, say, a period here at the end of a sentence. There's a point. Well, in geometry, a point is somewhere, imagine out in space, you have a point, a spot. Well, this area, it can be any shape. It doesn't have to be a circle. It doesn't have to be round. It doesn't have to be a sphere. It can be any shape, and it can be any size. It can be as small as you can imagine or as large as you can imagine. That would define a point. Now, whenever we're going to sketch it, for the simple fact of sketching and geometry, what you will see in any kind of geometry, anything that we deal with, you'll see just a dot on a line, and that's what it's going to represent as. You'll see a dot, and when we name this, you'll have point. We're just going to name this one A. Point A. That's a sketch of point A. Now, how do we name it? How do we name a point? We simply have the letter for that point. And we'll go kind of get in a little bit more detail on looking at that with our next one with a line. We'll talk about point a little bit more, but there's something very important about how we name a line. When we name it, and this is key, write this down, it must be capital. It must be capital letter. That's how you name it. It must be this capital letter right here in order to name a line, or a point appropriately. Let's look now at our next term, which is a line. A line is an object with no thickness. No thickness. That extends infinitely. If I could spell that correctly here, infinitely. In two directions. So whenever it talks about infinitely, that means it never stops. Now, if we're doing an assignment where you're taking an image, I would expect the line to go all the way across the image, and that's what we could say is a line. You could say it extends infinitely in two different directions. So let's look at a sketch. Let me go over here and grab a color for a sketch here. And there's a sketch of a line. Now, I'm going to write down here, this is an L, the lowercase script L. I'm going to put some points on here just so that way we can look at points. And we'll use this in naming it. Big key thing about a line is if you look at it, it has arrows on both ends. It's not just a straight line that's stopped. You have to have the arrows that shows that it's extending infinitely in this direction and in this direction. Now, just for the sake of X, Y, and that can be a Z. X, Y, Z. So now let's talk about how to name a line. We can name it this line right here in several different ways. We can take any 2 points on the line. So we can say an X, Y. Now whenever you name this, we have to have the arrows on each side. That is line X, Y. We can also name it XZ. There's 4 ways of naming this line. And then we have YZ. Now that's 3 ways, and we've used our points that are on the line in order to name it. And let's write in here, we're going to use it, using any 2 points, or we can name it using the name that's out here. Let me put a little line under that. That is naming this line. So we can also call it line L, which in this case it's not just a lowercase letter, it's a lowercase script, as you can see with the script that's drawn right here. Now, if a lot of you're going to name your own line, make sure, there's an easy one. Use the lowercase L. That's really easy to name a line. You can use that, or if nothing else, put points. Put points, that way we can see what the name of that line is. So now let's look at the line segment. Next definition, next term, line segment is a piece of a line consisting of 2 endpoints. It consists of 2 endpoints. And all points in between. So, if I was going to draw this out to the side, it's got 2 endpoints. There's an endpoint. Imagine that being a straighter line. And let's label this. This is X, and this is Y. Well, there's line segment XY, and it says it consists of 2 endpoints and all points in between. You can imagine there's really points on all these. You can put a point. You can put any kind of a point on here. If I come over here and grab and put a point, and I label that point C. Well, this line segment, it consists of these 2 points and all these points in between. So let's look at naming. How are we going to name it? We're going to use just the exact same thing that we used up here. We've got X, Y. There's 2 ways of naming this one. We're just going to draw a straight line over the top of that. That's not going to have any arrows on the end. That's going to say that it's going to stop. Whenever it gets to this point X, it's going to stop. When it gets to point Y, it's going to stop. And also, you can just reverse the order. You can say Y, X. Now, that will come into play, the order in which end that you have an arrow on next up with our ray. So now let's look at the ray, and let's look at a description of a ray. A description is a piece of a line consisting of 1 endpoint, 1 endpoint, extending infinitely in one direction. So, looking at the description of which, it's a piece of a line consisting of 1 endpoint extending infinitely in one direction. Now, a line extends infinitely in two directions. A line segment is just two endpoints. So this has one endpoint. So if I was going to come over here and draw this, there's one endpoint, and it extends infinitely in one direction. So if I drew it in this direction, and to show that something is extending infinitely, we put the arrow on the end. Now, I'm going to come over here. I'm going to grab some points. And let's see here. We're going to label this one X. I'm going to put a point here being Y. And a point here being point Z. Now, let's look at naming this. We can name this a couple of different directions, or a couple of different ways. We start out with an endpoint. Whenever you name this, start with your endpoint. An endpoint is going to be an X. That's got the endpoint with it. Now, we can either say X, Y. We can draw it just like this. We have an arrow. Here's where it stops. This is our endpoint. It extends infinitely going through point Y. There's going to be a bunch of more points. As you extend on this line, you could have infinitely more points. But to name it, you start with your endpoint. In whatever direction it goes, you find a point that it goes through, and it continues infinitely through. So, with this being said, there's another way of naming this. You can name it that, or we can name it XZ, also starting with your endpoint and continuing on. So we're going to start with an endpoint and any other point on this ray that it's extending through. That's how you're going to name it, those 2 points with a line over the top. This showing that this is the endpoint, and this extends infinitely through this point. So now that brings us to the opposite ray. Opposite ray description is 2 rays. We have 2 rays sharing the same endpoint. And they continue infinitely in opposite directions. It's key on opposite, which is why it's named an opposite ray. These 2 rays will continue infinitely in opposite directions. So I can draw a couple of these right quick. I grab the color for it. Put my 2 arrows. And let me grab a color for an endpoint here. XYZ. So there's one of them. If we're going to share the same endpoint and being able to name it, if there was another point out here, it could be an X or a Y. But using this, we would name it using an endpoint Y, and we have YX. That's one ray that's continuing in this direction. YX is going in this direction, and YZ is going the opposite direction. It's going that direction. So, and another way that you could look at it, and it could be named, draw this here. So a different way of looking at this is if both of these are point Y, this is point X and this is point Z. I mean, that's what we are technically looking at up here. We have our endpoint Y continuing infinitely through point X, and then we have a point Y that's continuing infinitely through point Z. So if you come up here to our line actually has 2 opposite rays in it because it's the same thing. I've drawn the same sketch here and here. So if we're going to name this, grab a color for that. If we're going to look at name this, we have an XY, excuse me, I'm sorry, a yx. Erase this here. We have a y. We have to start with our endpoint. We have a yz and a yx. We start with our endpoint. We have the arrow that continues through the other point, whichever direction the ray is continuing infinitely. All right, and the last one that we have on this page is a plane. Let's look at defining a plane. A plane is a flat surface. Flat surface that extends infinitely. In all directions. Plane, a flat surface that extends infinitely in all directions. Let's draw a quick sketch of a plane. Grab another color other than the green. Alright, so I'm going to draw all these arrows. I'm going to show this continues infinitely in all directions. Now whenever you see this, you could see a sketch of a plane and it's got points inside of it. A plane can hold points, lines, line segments, rays. It can hold all of this that we've already talked about. So let's point in. Trying to get an M here. M and point O. Now also what you're liable to see is it will be named with a script letter, an uppercase script letter. In this case I'm going to use uppercase P, uppercase script P for this sketch. Now we're going to talk about naming it. Using what we have right here, we can name a plane using 3 points within the plane. So I have here 3 points. Capital letters must be capital letters. M-N-O. Now for your notes here, put it must have 3 points. That's critical. You must name a plane using 3 points. You don't do anything over the top of it. That's all there is to it. 3 points. That's going to name a plane. Now, you can do that, or we can simply say this is plane. We're going to use our uppercase script P. And for our notes of this plane P, I'm going to put it is uppercase script. So you know when naming it, you have to use the uppercase of a script. This line is used with a lowercase. If you need to come up here with your notes right here, and let's put lowercase. So that's lowercase, and this is uppercase. So, our plane, and let's look at this real quickly, and I'm going to draw, let's look at the line segment. Let's find the line segment in here. Line segment, there it is, line segment MN or NM. It doesn't matter which one, however we want to name it. This could be, and I'll draw it right here. If I can draw it going through that line, through that point, excuse me. Go over here and grab that point a little bit bigger. So, there is a ray that's inside of a plane. Any of these things that we've already talked about can be held within a plane. Alright, so now let's turn to our second page. Let me clear out what we have here. Bring up my second page. And let's look at these terms real quickly. They should be fairly quick. Collinear. Collinear are points. Points that lie on the same line. So let's draw a sketch real quickly. Let's draw ourselves a line. And let's put some points on this line. And I didn't want to get that color. Let's remove that one. Here we go. Put some points on this line. I'm going to put points X, Y, and lastly Z. And whenever we're talking about naming it, it says how to name it. We're just going to say X, Y, and Z are collinear. That's all you simply do. You just say these points are collinear. They all lie on the same line. And I need to put my period about where it goes. There we go. Points that lie on the same line. That is collinear. With that being said, we should be able to figure out what non-collinear means. Non-collinear are points that do not lie on the same line. Move my period over here. So if we're going to sketch that and talk about it, I'm going to go ahead and draw a line. I'm going to come over here, I'm going to put some points. And naming this, let's go with X, Y, and this one over here we'll call W. So if we look at it, it's pretty obvious. X, Y, and W, they're not on the same line. So whenever we name it, we're going to say X, Y, and W are non-collinear. Pretty simple. So now we move on to coplanar, and using what we know of collinear, we should be able to define coplanar points. That lie on the same plane. Points that lie on the same plane. So a quick sketch. I'm going to draw a plane. There's a plane. I'm going to put my points, in which it really doesn't matter what points we use. Q, R, and S. Whenever we talk about this, we're going to say Q, R, and S are coplanar. And lastly, let's quickly define non-coplanar. Non-coplanar are points that do not lie on the same plane. Points that do not lie on the same plane. So to quickly come over here and draw a sketch. There's the sketch, and come over here and grab some points to put on that. I'm going to go ahead and I'm going to put my Q, my R, my S, and then over here, there's point T. To name it, we're going to say if something's not or non-coplanar, we're going to simply say Q, R, S, and T are non-coplanar. And that does it for topic 2.1. On topic 2.2, we will talk about some postulates, which are statements that are assumed to be true about our lines, our rays, everything that we've learned in this section.